Date?
Absolutely.
Is dated? Okay, I'm Mr. Brundage, and I'm the maker of a compound number 5. And this is my friend, Mr. Sherman. He's a pilot, and he's also an X-ray technician at the Community Hospital in Riverside. Some of the information on this materials here will be referring to Mr. Sherman on them because we want to verify some of its properties. We're going to be using MAP gas here, and what we'd like to do is we'd like to start with the original compound. This is a compound number 5, Mr. Sherman, and it's a solid. However, the compound that's in compound number 5 has more of the qualities of a high-grade epoxy resin or plastic, and that is not the compound. The compound is in the matrix of the material. Right now, MAP gas, which is the substance we're going to be heating with it, is methylated acetylene stabilized with propadiene, and this is the degree temperature by which the MAP gas is heated.
MAP gas burns at 5,301 degrees Fahrenheit.
We're using MAP gas. This is not propane. We're going to turn it all the way up. So we got basic flame temperature. Now, this first test that we're going to do, this is on compound number 5. First, what we're going to do is we're going to freeze this sample piece. This piece is taken off the same piece. It's just broke. We're going to heat that one. We're going to freeze this one here. So what we want to do to make the test fair, we're going to freeze this one and hand it to them and see if it gets cold, and then we're going to heat that one. So the best probably the thing to do here is take a piece of metal, and we're going to freeze it with some difluorothane, which we know difluorothane gets cold real fast. Would you verify that's cold?
That's very cold. Very cold.
All right, now we're going to freeze this substance, compound number 5, and we're going to see how long. We're going to really hold it on there and see if we can freeze it. Okay, so we can see the freeze coming up on it. And you feel the material. As soon as it condenses away, now you take it and feel it. Is that cold?
Okay.
Is it cool or is it cold? All right, this compound is my compound, and I'm going to try freezing it with this difluorothane here. This difluorothane in liquid form is very cold. So we're going to get this, see if we can get it in the camera. All right, so we put a lot on there, and see, it looks as though it's frozen. Is that frozen?
It's very frozen.
All right, how cold does that feel?
It's as cold as you can get.
Okay, now.
But you can't feel it above it, though.
Feel the surface now. Is that cold? Is it cool or is it cold?
It's cool now. It's cool.
So it doesn't really freeze like it would freeze metal if we were to take metal and freeze metal. So
it doesn't taste it with the camera.
Now metal absorbs cold a lot more. So which one absorbs the most cold?
This one will take more cold.
This one doesn't. Okay. So now we've established that compound number 5, it won't freeze.